Hello chemistry students, this is Mr. Ferguson and I'm here to introduce Unit 7 where we're going to learn about the mole concept. And this is a central concept in general chemistry and one that you're going to be using for the rest of the year. That is the skills and the things that you're going to acquire in this unit you will need in every other unit for the rest of the year. It's fundamental chemistry ideas. So let's get to it. First lesson. Alright, so the first lesson in Unit 7, we're going to take a look at formula mass and molar mass. And we have three objectives for you. First of all, to recognize Avogadro's number of things, note that things is in quotes so it could be anything, as representing a mole of things. Secondly, to calculate the formula mass of a compound from its chemical formula, and you just need a periodic table and a calculator to do that. And thirdly, to recognize that the formula mass is also known as the molar mass of a substance. So let's get started. So let's review. On the periodic table, there's typically two numbers published for each element. One of them is the atomic number. The other one is the atomic mass, which we told you before is the average mass of an atom of that element in
looking at a periodic table
mass units.
It would be for hydrogen that 1.00794, and for boron it'd be 10.811. So that would be our atomic masses that we're talking about.
Now, interestingly enough, it also just happens that the mass, the molar mass of the substance is also the same as the atomic mass for an element. So if you know the atomic mass, you also know how many grams of that substance it takes to give you a mole of that. And knowing the moles is very often what we need to know, because that's the true amount of something, the number of moles.
And if you're wondering what a mole is, it is the unit of amount in chemistry. A mole of things is a certain number of things. Use moles like you would use the word dozen or thousands. It's abbreviated MOL. And the number that goes along with 1 mole is 6.02 times 10 to the 23rd things. These things are usually atoms, molecules, ions, anything that we usually
electrons,
talk about. Yeah.
Right.
So it could be anything, 6.02 times 10 to the 23rd.
So the formula mass of something, we would use that term generally for a compound. It would be the mass of a single molecule or a formula unit if we're talking about an ionic substance in atomic mass units. And the formula mass is also the molar mass of the compound. So if you know its formula mass, you know how many grams of the substance it takes to give you a mole.
Okay, one short thing to take note is that AMU up there is also equal to grams per mole. So AMU is right up here. Just make note that AMU is equal to grams per mole. They are interchangeable. So
because molar mass and formula mass are interchangeable.
You'll see it both ways. Please don't freak out if you only see it one of the two. We'll use them interchangeably in class. The tests will have them used interchangeably as well. So just be aware of that. So lastly here, we want to calculate the formula mass / molar mass, and basically all you have to do is look at your periodic table and add everything up once you get the proper name down. So the first step for lithium hydroxide is to know how to, well, write out the formula. So lithium is Li plus 1, and hydroxide is OH minus 1, so this is an easy LiOH. And then you look at your periodic table that you have with you, and you add them all up. Li, you'll find out to be 6.941. O will be 15.999, often rounded up to, I guess we can't play with that, huh? Often rounded up to 16. And then hydrogen is 1.0079. And if you add them all together, you get...
What was lithium again?
Lithium is 6.941. Now with these are all given values, so there is no significant figure count on these.
Right. So you should carry it out
to the hundredths place, I'd say.
Yeah, the hundredths place. So so this should. 16.
That's fine. So it's 23.95 when we're all said and done.
And each periodic table will have those
Slightly different,
atomic
yeah.
masses carried out to different number of decimal places. So just use the one that you
Forget
have.
your unit.
Okay, so this would be grams per mole
All right.
or
And
atomic mass units.
Then the next one is carbon tetrafluoride. So you have to know that is CF4. So it's 12.011 plus 18.998 times 4, since we have 4. 18.998. Hit enter, and you get 88.003. 88.00, I suppose.
So if I had 88.00 grams of carbon tetrafluoride, I would have a mole,
Yes.
which would be a certain number of particles. So Avogadro's number, 6.02 times 10 to the 23rd.
And then the last one here, Mr. Ferguson was being kind of mean, I suppose, with the hydrate. So it's calcium chloride, that's CaCl2, dot 2H2O.
And the reason I threw one of these in there, we have bottles of this on the shelf and it's marked dihydrate, and if you need a certain number of moles of it, you have to account for the fact that there are some extra water molecules in there, and they are part of the mass of the substance.
And if you add it all up, we don't have to write this one out, I don't think, for him, but it turns out to be 146.99 grams, or something near that. Again, it depends on what periodic table you're using. As long as whatever you have comes out close to what we have, it's fine.
And if we didn't account for those 2 waters for every formula unit, we would get a much lower molar mass, and we wouldn't be massing out the correct
32,
amount.
so it'd be 114, something like that. All right, next slide. So just a little bit more practice. They want to know the mass of 1 mole of hexane. So
The first thing
again,
we have to know is
how to name what hexane is. So we
what
know
the heck is hexane?
So it's C, because we're going to say this is an organic compound. So it's C6, and
That's
it's
what
hexane.
the hex tells us. The ane tells us
It's
how many
2n
hydrogens.
plus 2 number of hydrogens, so it's 14. So then we simply add these up. 12.01 times 6 plus 1.0079 times 14. Most people round this to 1, but it's okay. Gives us a grand total of 86.17 grams per mole for hexane. Notice we keep having periodic tables in the top right. We can't read them and you can't read them. It's just to remind you that you need to have a periodic table to do these.
So all we're doing, these numbers, if you missed it the first time, those numbers right there, they're simply the atomic mass, and we're just adding up the mass of every atom in the formula. So there's 6 carbons, so we took 6 times the mass of a carbon atom, and we added that to 14 times the mass of a hydrogen atom, and that's our molar mass.
Okay, and next we have to determine the mass of 3 moles of water. Water is H2O, it's a very common compound, and it's roughly 18 grams per mole. Because oxygen.
So 18 grams per mole, that's 18 grams in 1 mole.
So then if you do
so 3
a conversion like
18
this.
grams per mole.
So
Well, it's 3 moles.
Yeah, 3
times
moles.
18 grams per mole.
So that means the moles will cancel, and you
50
have 54 grams
grams, moles divided
of
out.
water, if you really want to be specific. And that's how these are done. They're pretty straightforward, they're pretty easy, but again, if you can't name, you're not going anywhere. And if you don't get this basic step, you're going to have a very difficult time. We actually go into stoichiometry, where we convert grams of one thing to grams of another, and vice versa. So it'll be very difficult for people to move forward, especially if they can't do the first step, which is naming. So if you have yet to learn to name, come and see one of us.
I'm noticing a theme here.
Yes, naming. Please learn to name, and we'll see you tomorrow.
Alright, so to wrap up video 7.1, I've got 2 post-video questions for you. The first one is, what's the molar mass of carbon dioxide? So we first are going to have to figure out the chemical formula for carbon dioxide, and then reference a periodic table and figure out its molar mass. Second question, if you have 10 grams of lead-2 chloride, Do you have more or less than a mole? Explain. So the first thing you're going to have to do is figure out the chemical formula of lead 2 chloride. Remember, the 2 is telling us the charge on the lead ion. So once you get that, again, hit the periodic table, figure out the molar mass, and see if 10 grams is more or less than that. Good luck.